So my name is Elena Bondareva. It is terrific to be with you. And we're going to shift gears a little bit because this is the question that I have been grappling with for my entire life. So how do our jaw-dropping ideas actually change the world? How do today's outliers become the norm tomorrow? So I was a teenager in the imploding Soviet Union, which was at the time also the West sandbox for pretty crude experimentation in social and economic systems, when I first committed to figuring out how it is that we do change better in ways that actually preserve human dignity rather than obliterate it, in ways that open up possibility rather than lock us out of that. And that has taken me around the world because 70% of transformational initiatives fail. And that is a really stubborn statistic that has not budged for several decades. And yes, that is heartbreaking to people that are in the middle, like you all, trying to actually create a trend, different kinds of futures. But it also means that we're burning through people. We're burning through money, we're burning through goodwill, and we're wasting time. So across 6 continents, and 20 years of research and practice, I have been figuring out, well, how do we reverse those odds? And I've done that through work with a ton of different organizations around the world, universities, government agencies, private professional services, as well as having established or helped establish over 24 ventures of my own transformationally. I work across industries. I'm industry agnostic. So I've worked in blockchain and green building, in health equity, and how we integrate First Nations principles into building codes. So for me, it is really the mechanics of transformation. How do we understand it so that we can do it over and over again? Just like the scientific process is something that we can apply across disciplines. And in this work, I have identified 5 of the most common reasons why transformation fails that I want to briefly share with you as we frame the panel discussion for today. So the first one is that we do not differentiate transformation from incremental change. If incremental change fine-tunes the system, transformation reimagines it. It recasts the norms, the rules, the processes, the protocols of that system. Transformation takes us to places we have not been, just like we have not yet been to a future where engineering living materials have replaced and substituted traditional ones. We require transformation for that. But you also can imagine that going into, say, medical procedure, you would want to know if it's minor and you'll be home for lunch, or if it is major and they're going to keep you for 2-3 days. Being surprised by that, you would probably find unacceptable, which is why we are acknowledging that transformation is major change that needs to be handled accordingly. The next reason why we fail at transformation more often than we succeed is that we do not take care of process change. Not a single discipline that is responsible for recalibrating processes around the solution that is transformational. And what that means is that we need to understand that transformational change of complex systems is more like pulling on a spider web than it is like dealing with a spice cabinet or a Jenga tower, where each element is self-contained. When you pull on a system, the entire thing moves. And the moment you let go, it actually wants to revert to type, because complex systems like being exactly how they are, whether we agree with that or not. The third reason is that we don't design transformation for all of the things we do design, from the case of our iPhones to the sound of an otherwise silent electric car. We do not design change, reacting to it as it happens. And that is a huge disservice. Leaving change to change management, which is that a discipline some of you are familiar with, change management? So for most people, that might be the only discipline that they know addresses this. But leaving change to change management is like leaving fire safety to firefighters. They need to be our last resort. And everything else, ensuring that we're removing risk, ensuring that we're putting in place irresistible, intuitive solutions, needs to come first. The fourth reason why we fail more often than we succeed is that we don't actually think we can plan transformation. Even some of the most extraordinary change makers I know feel like it is really more chance than choice. That it is something that we stumble into even with our best efforts. I'm not too discouraged by that, because most of the phenomena that we actually treat methodically today, we used to think are unsteerable. And in that, transformation is, I believe, what parenting was a few decades ago, when parenting just was. It was haphazard. Kids just kind of grew up. And now you can't even look with your newborn baby without a class that is so explicit, they might as well tell you not to put your baby in the microwave, right? So we have learned enough that we now know developmental milestones. We know neurodivergence and its influence on development. We know all of these things, attachment theory. So now parenting is intentional just over the last several decades. And this is where transformation will be. Of course, this is where biology already is. A lot of fields of science, this is the progression trying to move along. And the last reason for this prolific and abysmal failure rate of 70% is we don't put the right people at the helm. If you think about it, both your dental hygienist and an oral surgeon are very important for your long-term health. However, you wouldn't expect the hygienist to implant. So why do we expect people who are in our HR teams, IT teams, general business units, people who are experts in that fine-tuning of the system, why do we expect them to lead transformation? They're not equipped for it. We're setting them up to fail. I want to illustrate the contrast on people like me. If transformation is about going into places we have not been before, I am the person who is very happy walking into a pitch black room, bumping my shins, hitting my funny bone, describing what's going on, lighting a few candles. When people go, oh, that's an interesting place, and they start moving in, I'm out, and I'm into the next pitch black room. And over time, the skills and expertise that people like us, the change makers, I'll talk about this in a second, need, they effectively amount to, I got shin guards, I got night vision goggles, right? Like, I do this for a living now. And so in that, I've identified a new psychological profile from my research that I call the change maker. And I suspect some of you will recognize yourself in these symptoms. So if you feel responsible for the world's problems you did not cause, feel compelled to intervene and see possibilities that other people miss, you might be a change maker, which makes you the world's most precious resource, because you're uniquely wired to lead this change, not alone. Need all kinds of other people, and I write and talk about this quite a bit. But the challenge is, if you are a biologist, a chemist, an engineer, you start with a base of knowledge. And you're only expected to innovate after that base is covered. Hey, even dog groomers and beauticians have that. Change makers have nothing. Everybody I talk to, we're figuring this out. And it took me over 15 years to actually accept that it is the mechanics of transformation that I'm interested in, and that it is my profession, because that's not an option from the LinkedIn pull-down menu. And so what that means is we are gravely under-equipped. Is it any wonder that change makers are burning out at precedented rates, as the research shows? And it almost makes me amazed that we still succeed 30% of the time. But it doesn't have to be this hard. So our impact in creating transformation has been haphazard. Some people describe it to me, maybe that's been your experience, as nearly assured self-destruction. So we need to shift that to an environment where we do acknowledge change makers, and that is my mission and my work, as essential. We equip, we support, we create the tools that are necessary. Because what could become possible if we did not leave change exclusively to chance? So in encapsulating everything that I have learned over my 20 plus years of practice and research, I published this book at the end of last year called The Changemaker's Handbook, which takes people all the way through. How do you define a world-changing idea? Then how do you vet it, fund it, build it? How do you change and rewire systems around it? And what do you look for? And ultimately, how do you exit, all the while keeping a smile on your face? It is available on Amazon. Learning from my experience from Australia last week, where I didn't bring any. I did bring a few, if you want one. So that's the book. And I'm not stopping there. So my current PhD research with RMIT University aims to produce an equivalent of the periodic table of elements, but for change. So imagine that future where all of the elements we know their inherent properties, we know how they react to each other, so that your work, if you're trying to create a future where we grow mycelium furniture in industrial scales, you go, well, which ones and in which order do I need in order to create the formula for the change that I want to see? So if this resonates, I'm actually sharing interim findings of my research via Substack. So please find, subscribe, let's connect, let's keep talking. So what does my work mean for living materials? It is one of the many industries that I've helped accelerate. And one of the specific projects that I want to mention is 4 years ago, I was engaged to help a Department of Education in Australia replace traditional building materials progressively with living materials. And that is a project that I was on for 3 years. Unfortunately, like so many of us have learned, it did not go to plan, and a change of government halted the whole thing. But that's how I met many of you, including the INM team. But we developed a discussion paper, sustainability strategy, in which we built in the room for living materials. And we went out for what we understand to be the world's first RFI globally for engineered living materials for the built environment. Heard from a lot of people who are even going to be on the panel and beyond that. And then in 2020, actually developed a business case and a whole pitch for how to position a hub for engineered living materials in the state of New South Wales and Australia. So found the site, I spoke with regulators, I spoke with tax office, I spoke with border protection so that we can actually have genetically modified materials coming in to varying extents of success. But effectively, that building blocks that I've described, starting to cover a whole lot of them. And then we procured a bench, Airform 1, and actually had to send it back because it did not pass Australia's very stringent border protection laws, and that was pretty heartbreaking. But it actually illustrates that point that I made about process. At the end of the day, it came down to a form. And there was not a box for them to tick. They didn't know if it was timber or this or that or the other. And so this is where this transformation, we're not short on ideas. You have shown this to me just over the last day and a half. You're not even short on proofs of concept in a lot of places. What we're short on is implementation that takes this and requires this methodical approach. So part of what I demonstrated, and this is one of the building blocks, is a glimpse at the future. One of 60, I've identified over 60 building blocks now. And so in building that project, illustrating to these government and kind of adjacent stakeholders what that future might look like. Some of these material creators are here in the room. Articulated the benefits, the like-for-like comparison. Using the words and language is another building block. If you remember 1984 by Orwell, if you don't have a common language, you just can't even move past that, right? So in Australia, circularity is the word that we hooked ourselves onto. But whatever the words might be, being very strategic in how do we communicate the message of why living materials are worth a go. We also identified through interviews with a lot of creators what are the main obstacles. And of course, the panel that we're going to invite in a couple of minutes is going to look at that. But awareness, right? Mycelium, is it going to be slimy? Is it going to grow? And of course, I'm like, well, if you cut a stinger, it's not going to grow in air as it heals, right? And of course, I'm not even a biologist, but we can explain to people why they do not need to fear what it is that they fear. And humor is another of the building blocks that I've identified. So yesterday when Luca talked about puberty as something we can all relate to, all of a sudden the whole room had a different level of energy because it was funny, it was timely, and it's one of those building blocks that as change makers you can deploy very strategically. So now, hopefully with this timer, you're ready to dive into the roundtable on how we actually drive and accelerate change towards living materials. So I'm going to invite my panel, and Shirish is going to introduce them while I come down. So just before I do that, we will have some questions. We prepared some. We will start the discussion. However, this is very much for you to jump into, as I've mentioned, hence the change in the layout. My only request is most of the conference has been really technical. So we want to reserve these couple of hours for questions about commercialization, about what the experience of those creators was going from academic to industry. So if you have really technical questions on the molecular level, just hold them until the drinks are served. Also because then I can actually understand the question. All right, you want to introduce?
Yeah, thanks a lot, Elena. It was a wonderful start to this panel for this roundtable discussion, and I'm really excited to be here. Actually, we've been doing this since the first conference, and even some people like Neil Joshi and Avi Schroeder were there in the panel before. So I'm glad that it's evolved to this state, and now we've even made it much more exciting at the start. I think I'm just going to call up our members one by one, and they get a moment to tell you something about themselves. So first I'll start with Melanie Fessel from Terraform.
Here we go. Well, thank you for this invitation. Thank you to Elena. Thank you to Shirish. I'm super excited to be here today. I'm Melanie Fessel. My background is architecture and urban design, and I'm part of a nonprofit organization called Terraform One, based in New York and Europe. And our focus is on socio-ecological design. So we design everything from the doorknob to the democracy. And just to give you some visuals today, I brought a series of a few projects that I've worked on with my group. And here was our question, why grow a surface? Because we can, and here we see the beginning of our mycelium bench, where we built a DIY biology lab in Brooklyn, where the FBI came to see what we're doing there. But we managed to grow this very tiny chair. We had a lot of limitations, the size of the refrigerator where we had to store the mycelium. So it was a very long process. We worked on this project for over 10 years. But it actually developed, here you can see it further, into something that really rethinks what a chair is, and even further, how can we use this to create our buildings in the future?
And that is the bench we had to send back with tears in our eyes.
Yes, exactly. But it can be an interlocking wall system. It can be used for insulation. It's super inspiring to see a lot of these posters that also research on the extreme potential that mycelium actually brings to the table. But of course, as an architect and urban designer, we work on many scales, but it's really about the implementation within architecture and designs that we aim for. Just to give you like a broader perspective of what we do as a nonprofit organization, the UN has mandated that we rethink our food production and basically find more healthy resources for protein. So we designed this cricket shelter because we were tasked with the design of an emergency shelter. So we thought, why not combine the food production with a shelter in itself? So we created this facade where crickets are very happy to mate, reproduce, die, and then being used for food. And hopefully this inspires many people to rethink the livestock issue that we're globally facing. And just another one of these projects, I showed you a surface that we grew, but also for many years now, we've been working on growing buildings. So actually, this is a living material. It's a very old technique. It's crafting trees into specific shape. We're, of course, also interested in computational design. So this is, why for us it has to look interesting and inspire some feelings in people. But basically, we managed to build this building. It's upstate New York. And hopefully we can all live in grown shelters in the future, because I think it's a much healthier environment. This to say that actually 90% of our time we actually do spend indoors. And I think for all of these different concepts that were presented, there are huge applications also within the construction industry that would be very interesting. Thank you.
Wonderful. Thanks a lot. Be cool. Willie. Yeah. Okay, then I'm just going to go in this order. So Martin Dade Robertson's up next, Professor of Architecture at Northam.
And to the tech team, we can put it back on the...
Yeah, I don't have a presentation. I was a bit of a last minute hire. I'm Martin Dade Robertson. I'm the Professor of Emerging Technology at Northumbria University. I founded a research centre called the Hub for Biotechnology in the Built Environment, very much in theme with what Terraform One do as well. And within that, I co-lead with Meng Zhang, who's somewhere in the audience, a research group called Living Construction. So we work on engineered living materials at different levels of technology readiness. So we go right from molecular biology through to things which we hope will be able to scale. We're an interdisciplinary team, so there are about 20 of us in the group at the moment, from molecular microbiologists, material scientists, through to architects and other sorts of designers as well. We're actually quite well represented in this conference. So I think there are probably 4 of our posters at the conference. Katie, one of our postdoctoral researchers, presented earlier today. In fact, the watch strap that you called me a model. It's the first and last time I will get called that, but I have a genetically engineered watch strap if anyone wants to see it later today. So we're obviously working at different scales. We're trying to prototype those. So one of the things that we're trying to do is, while we really enjoy and find the fundamental science inspiring and exciting, we also have an application in mind for each of the things that we do. And I said before, we work at different levels of technology readiness. So a lot of our fundamental research is TRL level 1 to 2, if you know about TRL levels. But we're also increasingly working with industrial partners now to try and scale up and actually make real materials. And we find that the challenges that they have and the kind of the research challenges that we have to face in doing that scale up is very different from what we have in the lab. And so it might come up later. But so yes, that's me.
Thank you.
Thanks a lot, yeah. Marty's watch strap definitely deserves a round of applause. Genetically modified. Yeah. Next, Michael Fergens from MF Biotech. You can just take that one.
Yeah, first of all, really great conference, great presentations. I'm really, really happy and excited to be here. So again, thank you so much for the invitation. Yeah, my name is Michael Fergens. I have now approximately 17 years in biotech and 17 years of professional experience in biotech and pharma industry. 5 years ago, I founded my own consulting firm. My work focuses on the development of innovative biopharmaceuticals, including genetically modified organisms for unmet medical needs, but also in general cell and gene therapy. So I work mostly with biotech startups and medium-sized pharmaceutical companies. And I support them in the areas of development strategy and regulatory affairs. So the typical project or the typical work I do with them is they come with a preliminary data set from research and development, maybe also non-clinical data, and we figure out what would be the appropriate path to a first-in-human study. What would be, how do we interact with regulatory agencies, and so what are the regulatory requirements to start the clinical development. The reason why I'm specifically here is in the last 7 years, I have been working on a project which is a genetically modified organism, and I supported the company since preclinical development. They are now in phase 2 clinical development, and we were very excited that we got a prime designation beginning of this year. For those who don't know, this is a specific designation that is equivalent to what the FDA has as a breakthrough therapy, and this is supposed to accelerate the overall development. So what I can contribute in this panel discussion basically is from the biopharmaceutical industry perspective, development and regulatory affairs perspective.
Thank you.
Wonderful. Thanks a lot.
Hold on to that, Mike.
Next, along the lines of living therapeutics, you have Caroline Kurtz from Synlogic.
Thanks so much. It's great to be here, and I think this is probably the most diverse group of scientists and technologists bringing novel technologies together, and I just love it. So thank you so much for including me. I am Chief Development Officer at a small biopharma company in Cambridge, Massachusetts in the U.S. Called Synlogic. And we have been pioneering developing living medicines through engineering in an organism that is familiar to many of you here, E. coli missile. And this company was founded in 2014 by a few professors at MIT, Jim Collins and Tim Liu, who were very excited about making use of all the great synthetic biology they've been developing in their lab as therapeutics. And so they brought it to some investors, and Synlogic was formed based on the investments, particularly with a venture company called Atlas. And so I was brought in to the company in 2016 to really lead drug development. I'm not a synthetic biologist. I've learned a lot from working around synthetic biologists. I'm a scientist by training, but my career has been in drug development. And I've worked in small biopharma companies for about 27 years now. So it's I love seeing technology transform into products. And I've worked on everything from polymers to peptides to synthetic microbes. Synlogic, during its tenure, has brought 6 strains into the clinic and demonstrated that they're safe, well-tolerated, and have demonstrated activity in the human GI tract and in tumors. And the furthest program along got into phase 3, and that was a strain for phenylketonuria, which is a rare inborn error of metabolism disease. And the strain is designed to break down a dietary component, phenylalanine, that is toxic for these patients. And so I've spent most of my time working on this one program, but we had many other programs as well. And unfortunately, we didn't make it through phase 3, and so the company has had to shut down. But we learned a tremendous amount during this process, and I hope that I can share some of the learning with this group as others think about taking their programs to the next developmental stage. And I think even if you're not doing therapeutics, there's common themes here about the health of the cells, metabolic activity of the cells, the scale-up of the cells, keeping them alive in the environment that you actually want them to perform in. So I hope that we'll...
Wonderful. And it's important to note that phase 3 is the farthest any engineered living therapeutics has gone to so far. Yeah, next we have Johan Bauerfeind from Solaga and Berg Labs Bio.
Yes, hello everybody, my name is Johan. My journey into living materials, not engineered living materials, but living materials, already started about 10 years ago when I started the first iChem team in Berlin. And back then, I wanted to bring something to this iChem competition that was very typical from Berlin, and that was the design and the arts community. Back then, I already realized what kind of treasure it is to get your ideas analyzed again from a different perspective. And from there, I kind of developed my practice, which includes always the inclusion of designers and artists, and to combine them and to empower them with biotechnology. After iChem, I left university. I did not do a PhD or something, but I founded a company, Solaga, and we were focusing on cyanobacterial biofilms. So basically sheets of microalgae that we used for cleaning air, but also cleaning water, but also for interior design products. And we basically created our materials and we pushed them into the market as quickly as we could as an end user product, meaning that we have over 300 customers until now. And later, after the end consumer products, we actually went more into industrial projects with these materials. But basically, I know what it means to have a living material in the market. It's not GMO, it's not engineered, but I've been through it. I've learned a lot of lessons, and I'm happy to share these with you today. And also coming from a biotech background, but working always with designers, I was asked about 4 years ago to join the Borg Labs. Borg Labs is a initiative from the University of Arts and Design, Borg Giebichenstein in Halle, where they basically created a biolab in an art university, one of the first ones, actually back then. And we basically have an open workshop for all the design and art students to come in to work with biotechnology. We have people to help them to get a start. And since then, a lot of cool projects happened. And I'm really enjoying to combine these two fields.
Keep the mic.
Wonderful.
You're good. Thank you.
And I can recommend some of his products. We bought one some time ago, and it's pretty cool paintings and so on, made of algae. Yep. Then next we have Scott Walper from the Office of Naval Research. So very important for funding.
Yes, so thank you again for inviting me and let me participate in the panel. This is my second European ELM conference, and it's always a great event. I'm happy to be here. So yes, I work for the U.S. Navy for the Office of Naval Research Global. So I'm a molecular microbiologist. Before I took this job, I worked for the U.S. Navy at the Naval Research Laboratory in Washington, D.C., where I did the same as the rest of you. I wrote a lot of proposals and papers, begged for money, and did research in bioremediation, biomaterials development, and the like. In 2022, I took this job because we had just come out of COVID, and I had been locked in my house for 2 years, and I was ready to hit the road. And so now, as a science director for the Navy, what I do is I travel the world to meet researchers from academia, industry, and government to say, what are you doing? Is it something of interest to the U.S.? And to find a way to help you partner with either U.S. researchers or U.S. funding bodies. So ONR Global, who I work for, has actually been in Europe for 80 years. And we fund very basic foundational research that is typically agnostic to an application. So we're not looking to build anything. We're just looking to fund crazy blue sky type science to push the field forward. So the U.S. Navy tends to be very risk averse when it comes to what we invest in. And so we offer a funding stream to explore those crazy BEV-NAP ideas you have where you just kind of jotted it down while you were having a conversation with your friends. That's the type of research that we like to fund and what we'd like to do for the community in order to push it forward, because you never know where the next great discovery comes from. So while that is what I do primarily as a representative of the U.S. Navy and the U.S. Department of Defense, we also like to help connect researchers who are farther along on the technology readiness level that Martin mentioned, in order to give you access to the capabilities that the U.S. has. So the U.S. Navy has some 23 different locations and research laboratories that are filled with scientists and engineers that have cutting-edge equipment that allow them to test things as they move along the TRL scale or the MRL scale. As an example, the U.S. Services Department of Defense is investing very heavily in scale-up technologies, and so across the laboratories, they have stuff that allows you to take your material from the 1 mil scale all the way up to, I think the Army has something like 10,000 liters at this point. And along the way, they'll test and help you understand your technology and the pitfalls. So one of the things that we do, or what I do when I travel, is I try to hear where you are with your research and try to help you connect with somebody in the U.S. Because as we discussed today at lunchtime, often when you're thinking about a material or what you're developing, you don't know what the specific factors or limitations or requirements are going to be. And so it's often good to have a transition partner, or at least someone who can give you that initial guideline of, we want this to work at 85C or be able to function at minus 20 degrees and a few bars of pressure in the ocean and the like. And so this is what we try to do.
Terrific. All right. Well, we're about to shift into first questions, but this is an invite. Can I have a half a dozen people just come up to the front? Also, the benefit is you get to stretch your legs and get a little oxygen into your bloodstream. So come up, just a few. From the back rows, you can do it. All the A students in the back, come on. All right. So just a couple more, just come up because we really want to have this more as a conversation. You see this as a really diverse panel. I'm probably not overstating. Thank you. Appreciate the movement. That probably most of us don't fully understand what each other does. And that is exactly how we planned it for you so that you can get this cross-disciplinary perspective on these questions. All right? So I'm going to go straight in to something juicy, and that is stigma. So I want to ask, and you can answer whatever order you want. So fundamental engineered living materials are, of course, genetically modified, GMOs. And most consumers have been really well conditioned that that's a bad thing, right? In fact, stamps that something is GMO-free means it's good for me, it's good for the planet. So what is how is that stigma affecting you? What are you doing about it? And what should we collectively be doing to counteract that?
Because we certainly encountered this, particularly not in the U.S., because the FDA doesn't really care if it's GMO or not. U.S. population is kind of mixed, on that. So that wasn't really a barrier in the U.S. But when we wanted to do larger clinical trials, we needed to expand beyond the U.S. We wanted to go to Canada, we wanted to go to Europe. And particularly here in Europe, we got into some issues where we had a very enthusiastic clinical site. We had a very enthusiastic investigator, but the country did not know how to deal with the GMO. They dumped us from agency to agency. We were in the Environmental Protection Agency, and then we were in the Ministry of the Environment, which were actually two different agencies in this country. And they were bouncing us all over the place. We couldn't get approval. And then they decided we were a gene therapy, and so we could only administer our treatment in a clinic. Now, we were developing an oral therapy that had to be taken 3 times a day by patients with a rare disease, and so it's just completely not viable. So we actually couldn't start the trial in Europe because of that. So I think that we need to change, we need to educate, and we need to dispel some of these scary things about GMOs and whether they'll transfer genes or not, and show with data that they're safe.
Maybe I can just add to this one because I have experienced the same. And the problem with the GMO regulation in Europe is that it's very different from each country in Europe. So usually the agency, the competent authorities that approves the trial is one, and then the GMO authority who also has to give the approval is another one. You have to do an entire environmental risk assessment, which you also have to do if you have agricultural products, if you want to, so a completely different type of product if you want to test this or introduce this in the environment. And here I really can confirm what Caroline concretely really explained. Here we have to get better in Europe, but this only can be done in cooperation also with the policymakers. On the positive note, in my experience in the past years, it has gotten better because also the field of cell and gene therapy has evolved, and even for other therapies that are also modified cells in a broader sense, you have to do the same. And of course, the regulators have to take a pragmatic approach at some point.
Who else? And what are you calling your work? Because I know that not all of you even refer to your work as ELMs or engineered living materials. So as you answer, kind of weave that in.
Yeah. So, like for in my daily practice, or also like at Solaga, we never encountered, since we don't do genetic engineering, never was an issue. And also customers, they never asked about it. So for them, but then for them, it was like kind of a lot of the customers, especially the end consumers, who would basically get like a greenery item for their homes or for their offices. Of course, they didn't have the story of genetically modification in it. And it was also in most of the project, it was really not necessary. And I feel like that genetic engineering is like maybe like outside of pharmaceutical products. It's not always present, like to talk about this topic, because I think a lot of the users of living material or also other solutions, they have other things in mind sometimes. So I think maybe sometimes we are a bit too focused on ourselves here. And in my experience, I'm also working in an art school where there's a practice of critical thinking. If we have a project that goes into genetic engineering, or mostly we cannot do it out with ourselves, but we go to partners and visit the researchers and they explain what they do, usually then the temperament completely changes. So once they get to know about it and they understand what's the reason behind it, then it's not a problem. So it's not a big issue from my perspective. And I wanted to quickly say something about how do we talk about our work. So I remember when we first started Solaga, and you always have to talk to people because you have to explain your products and what value you actually give. And you start talking about like cyanobacteria. Of course, nobody has a clue about it. So at some point, to make it easier, we were talking about, okay, let's say microalgae. Then we go to a science conference, and of course, all the biologists are like, no, cyanobacteria are no microalgae. Right, and so it really depends, like what kind of language you speak, what words you use, and sometimes you have to find your own wording, and sometimes this is the wrong wording. Like when we talk about our products, we just say algae, and most of the people cannot really distinct if it's algae or moss, like they don't know the difference. And then it's our job to explain them what is the value in it, what's better, what's maybe where do you have to adapt. But yeah, you have to really be adaptable, especially when you bring products into the market and find the right language.
Sure. Martin? We're kind of doing the mic sharing, people at a time.
I'm surrounded by mics, so I don't know which one to go for. I mean, I guess I would just add to the idea. So we do GMO stuff, and sometimes I deliberately use that as a provocation, right? So people in an architecture department get kind of both scared and excited when you say I have a GMO, whatever it is, building. But what we have found is that in applying for grants to do environmental type stuff with GMOs, we do get into a bit of a bind with this. I mean, there are certain grants where we if we wanted to make a material that we want to test in the environment, we did this with a cement-based grant. We had GMOs as part of the synthesis of the cement that would then go into the environment. We then had a work package where we could demonstrate that we could absolutely kill all of the bacteria before it went in the environment. Of course, that's an incredibly expensive and chemically, difficult step for particularly large-scale materials. And so we were criticized in the grant for having this step, which would make the product completely uneconomical. And so you have to respond in your feedback to say, yeah, and we would have to accept that we wouldn't be able to have that step, and therefore legislation would have to change. However, if we can prove this amazing concept of a CO2 sequestering cementitious material we can implement really easily, which is the kind of concept, then we might have to change those things. We didn't get the grant, and I'm not saying that was the reason we didn't get it, because I'm sure there are other things, but you do end up in that bind that I don't think in a sense there's anything preventing us from doing the work in terms of the existing legislation, and I wouldn't want to be putting things into the environment that we didn't fully know and characterize and have safety for. But there is a kind of feedback loop that says that that's part then of your proposal that then makes what you're doing, and so you're having to predict a change, and so we get into a little bit of a bind that way sometimes, I think. I think this is true of environmental applications particularly. I think there are lots of grants when we do those things that we can't go down that route because we know that we're going to get blocked.
Let's just stay with the branding and marketing. And I think, Martin, you were mentioning that. I think Melanie will probably have something to add to this as well. Very often, and I work with advocacy people, right? Hardcore environmental, social equity. And there is often, just like I suspect there is with scientists, a resistance to go into the marketing and branding side of things, right? Because facts are facts and everything else gets murky, gets uncomfortable, and yet taking these ideas from prototypes to changing the world requires that we cross that murkiness. So any thoughts on to what extent we need to brand or rebrand living materials based on what you're sharing now? Who should that sit with? Are any of your groups trying to give it a go at kind of the better story and a more compelling story around something this technical with a little stigma attached in some communities?
I can start, but I don't want to dominate the conversation. So we certainly are. So by scaling up and presenting materials and bringing them out into the context. So we spend some of our time at conferences like this, but we're increasingly in design festivals and trying to produce things that people can see and interact with and are really tangible. And so we do that. I think one of the challenges that we have, I think the art of persuasion is actually more within the academic wheelhouse than you would necessarily think, because we're also in the art of getting funding, which is the art of persuasion, every bit as much as it is the art of good science, it has to be said, and more so in certain contexts. So we do that, and I think sometimes on that basis we actually overclaim what we might be able to do or what might be capable, and so there is a danger there. I think the greater concern that I have, though, is also that we are not necessarily in control of the narrative once it leaves the institution. So we did talk yesterday, and I think there were some other people involved in that conversation, that we are in control of the point at which the press release goes out. But I've seen some quite extraordinary proliferations of misinformation based on a very poor understanding of the science, that have either largely kind of ignored what we're doing or taken it at a completely different level and made claims about it. We have no control over that. There's you can't change that proliferation, but you get information that's put out in that way, and we have no way of dealing with that. We've just got no way of controlling the message at all, which I think makes some academics very, very resistant to even communicate those initial ideas for that reason, because sometimes you get tainted by that as well, as if you were the one presenting those things.
And Michael, you were mentioning yesterday that it can be a hit to credibility, right? When people take out of context what was a story, what was this painting a picture of the potential, so that, to Johan's point, people can actually see where is this going, this very technical, tiny little bit of science, and at the same time, the hit to credibility. Do you want to give us an example, maybe?
Well, maybe not a concrete example, but I think it's pretty logical. If you put out a press release, it's and nowadays in the internet, it's all documented for eternity. So people read it either immediately, or they might check if it's a company, then it's really a part of your track record. They go back to you. Then if you overpromised, for example, or you also, how do I say, you bended basically the key messages of your clinical trial results. Later it turns out not to be true, because then investors, if you do a due diligence, they are digging deeper. They see the inconsistencies. It falls completely back on you. So I would completely discourage from such a behavior. Yeah.
So what do we do then? And this is, again, an open question to everybody, because I think what you're really describing the risk of, if we actually paint the picture, if we actually invite people to imagine these futures they haven't experienced, your head is on the chopping block. And so you've done it a couple of times, and then you're like, not doing that ever again. So how do we thread that needle? And what maybe has worked for various of you? And Melody, I'm looking at you, because design has been, and visual communication has been, one tool that obviously is used a lot to overcome some of that, right? To invite people clearly into visualization that is not reality. So just maybe starting with you, and what else works for you to be able to tell compelling stories without getting your head chopped off?
Yes, so maybe for us, it just always starts like with this process of developing, let's say, the chair or something that has not been done. So we really like testing the application, the scale. We also have a lot of failure. But once we're able to generate something, I think there's always this aspect of art within the experiment that we do as well, because art also gives us a lot of liberty. And if you're dealing, for example, with the New York City building code, and, we managed to build a cricket shelter that you cannot place on any public site within the United States, you just simply make it art. And it's just a very different way of how you communicate some of these heavier topics of, live materials that you can interact with. And so, I don't know, maybe it's a bit of a naive quality, but I think oftentimes it's also where you manage to bring together very different disciplines, because museums, galleries is actually oftentimes our platform where we also meet and engage with people. And of course, museums as well. So museums always love our work and they also present it. And I think with that comes a little bit of this engagement of topics that maybe also relate to engineered living materials and bringing it into a broader discussion point.
Mm-hmm. So pharmaceuticals as art, is that a possibility?
Well, I can. I wouldn't call it like this, maybe, but I think what you also mentioned, the approach to branding or to communication is interdisciplinary. You need the scientists who know exactly the data, but maybe you need also people who are specifically skilled in communicating and writing it up and presenting the data in a compelling way. Sometimes it takes also an iterative approach. So everybody who has pitched to investors, first you try one way to present your data, and then the next time you see that not everybody is convinced or not everybody understands what you want to convey, then you do it another way, and it's getting better and better, and also without losing the accuracy. So I think what I want to say is you need more people to come up with probably the most compelling message that also reaches as many people as possible.
Yeah. Well, and it's critical to know your audience, right? Because I talk to very diverse groups of people when I'm trying to convey what I'm doing, right? One day it'll be an admiral, some days it'll be someone from Congress, and then sometimes it's scientists who actually understand. And so you have to adjust your message and the story you tell based on who you speak to. And so I remember the first project I pitched and someone was coaching me. And again, when you pitch to the Navy, you pitch to people who are in radar, who are in materials, who are in undersea warfare. And I do molecular biology. And so I get up there to pitch my idea and I'm talking about promoters and gene regulation and transcription factors. And they're like, no. The person who's coaching me says, you have to understand that everybody's very different. And then you adjust your language to say this is an off-on switch versus the promoter. And so, as Martin said, as a scientist, you're very much a salesperson. But that kind of goes back to what you said in the beginning, is that sometimes you can't fill every role as you move your company forward, as you move your science forward. And sometimes you need those people who can tell a story, right? For me, I'm very lucky because when I sell things to the Navy and to the government, I get to tell fantastic stories, right? The U.S. Department of Defense loves science fiction, right? They want to see rocket boots and they want to know that someday you guys are going to help them swim like a shark. It might not ever happen, but these are the stories I get to tell, that I get to piece it out and say we're going to get there with ELMs, with synthetic biology and the fact. But it's critically important when you think about your branding to think about who you're talking to. If I talk to my mother, I'm not going to tell her about engineered biofilms, right? I'm just going to tell her the protection it offers in her house to breathe and to purify the air. So it's critical.
Sure. Well, before we switch gears to the next topic, any faux pas in communication? Any examples of when you said something that you just want to make sure we do not repeat? Something that was taken so out of context, words that you do not recommend using, anything like that? Or mismatches in your audience and presentation? I can start with just a non-related example to living materials, but I was a Russian moving to Dallas, Texas when I was 15 by myself. And I asked my volleyball coach for a strawberry cocktail on a Saturday at about noon because the literal translation for milkshake at McDonald's was cocktail. And I got an incredibly just a bewildered look, and I was thinking, this woman's going to report me. She didn't know what to do with me. And that's just an example of lost in translation, right? But science, we actually talk about translation. We talk about technology transfers, right? So any stories that might just, if nothing else, put a smile on our face of use of words and what not to do.
I would stay away from calling our products anything to do with the microbiome. There's so much good and bad and baggage around the microbiome and microbiome therapeutics, and we are not microbiome therapeutic, and these are very sophisticated, engineered, targeted, designed therapeutics, but we were constantly being thrown in the bucket with microbiome. Okay, it's just something to watch for that, is very distinct.
But what's the negative connotation with being linked to the microbiome?
Well, I think there's been numerous attempts to develop therapeutics from the microbiome, everything from fecal microbial transplant to consortia of organisms. And there's been a lot of failures, and there's been a lot of recognition that we really don't understand what's going on when you try to modify the microbiome. And so there's this sort of running away from the microbiome, it's particularly in the investment community right now, that you just don't want to be in that space. Okay.
There was one hand raised, actually.
All right.
Audience, I can bring a microphone.
Yeah, I have a suggestion which is coming from the great synthetic biologist Victor De Lorenzo. And he actually calls on all the scientists, all the academics, to not use the term GMO anymore, but to use a term symbio or something similar, because GMO as a term seems to be contaminated. And we can talk to people and try to convince them, but it seems to sometimes be an emotional discussion which we can never win. We can never give the rational arguments that convinces them. And even in the supermarket in my hometown, it says all our products are GMO-free. So this is an easy thing that we can do. Maybe we can use a new term, even though it's the same technologies, but it's more advanced. And we have scientific proof that it's safe.
Yeah.
So that would be my suggestion.
No, so appreciate it. And just an example, because I was even looking at the posters around campus around sustainability. Remember how sustainability was a new word? Now sustainability means almost nothing. So another thing to keep in mind, and that's the role that the Institute to some extent will play, is terms also go in and out of fashion. So while we need to be aware, what is the audience, what are the words that they're using now, it's never good for a transformational industry to get fixated. Like I've created sustainability strategies without a single mention of the word, right? Like you say, you code them in whatever words. So yes, for now, if it's synbio, and I'm just flagging that when it stops being synbio and becomes something else, move on to that. And don't get too attached. Go ahead.
We had the conversation last night about the natural and the artificial.
I was hoping to bring up Aristotle.
Okay, so Aristotle. So I've not read Aristotle, but I've read people.
Has anybody read Aristotle? Okay, yeah, nobody.
That's good.
Okay,
and I'm not safe ground with this audience. I've read people who have. There's a distinction made, and so one of the things that I was trying to get to as I was starting this is the distinction between the natural and the artificial. I think there's also an important legal distinction in relation to genetic modification. So what is a natural thing and what is an artificial thing? And there's been lots of attempts to define it. And one of the definitions is straightforwardly from Aristotle that, well, not straightforwardly actually, but there's the natural. The natural is formed through nature's own agencies, and the artificial is formed through forcible constraint. And so when you get into the world of biotechnology, that becomes a very challenging area. So there are some examples of a sort of a glass blower. Actually, glass is a natural product because it's using the natural material properties to achieve what it's doing. But there are other things where the materials are strangled or otherwise turned in. So there's a very strange set of categories there. But the idea is if you apply that to the biotechnology world, a lot of what I hear from people who do synthetic biology, for example, is we've been genetically engineering for thousands of years through crossbreeding, actually systemic genetic engineering in a way that actually our modifications now look comparatively minor. But the difference, I think, is that one is utilizing nature's own agencies, evolution through selection, even if it's us doing the selection. The other is perceived as being through forcible constraint because of the paraphernalia of what we do, because it's people in white coats in sterile environments with pipettes, with Philip Glass music playing in the background. It's that notion of the forcible constraint. And so I think sort of reclaiming what natural and artificial is part of this as well, because a lot of what we're proposing are natural alternative to think, natural polymers and natural biominerals and so on that we're actually utilizing. And the word natural feels like it's a much more, we're intervening, of course, but I'm not sure how we reframe it in that way. And when I saw that description, it felt true to me that was something that people are not reading Aristotle and saying that's my category system, but I think it's something implicit in what we're doing that is probably not helped by the way we present in conferences like this. We engineer life and these sorts of things, but we're not really doing it.
There was no music in the background.
There's no. Whereas last week we could have done that. I got Spotify if we need that later. So.
Michael?
Yeah, I just wanted to comment briefly on the branding or the wording discussion. We can, of course, call it however we want. However, now I have my regulatory affairs hat on, and there we should refrain from, so everybody uses a different word. So the regulators themselves, they have their regulatory boxes with a specific terminology. And this is also good because then they know what they are dealing with. And for example, GMO is one, or also gene therapy. So in the EU, we have specific categories for ATMPs, and these branding or these categories, we must respect them. We cannot just reword this because we think we can use then this wording also for other purposes.
Thank you. Johan, you showed me the publication that you make from kind of with your students and at the art school. So how do you thread the needle between storytelling and scientific fact? And anything you sort of want to add to that?
Like it's part of the education program of our students. I think, like especially in design, one of your main skills that you learn is how to document your work and also to document it in a fashion so somebody else interested to actually look at it. But it also just shows the quality of your craftsmanship, right? In the end, it's a really hard process, and I'm really happy. I have this biotech degree, and I didn't have to go through all the tiers that the designers and artists are going through sometimes to find their own identity, artistic identity. But it's something they have to craft really themselves, and for that they need to work on their documentation. And storytelling is just part of the craftsmanship, what they do themselves. And for us, it is just really good to have these small publications that are just like small books, like for us, but also we give it to all our partners. We give it to potential collaborators, to you, some of you, I give some. Just so, we don't have days to talk to each other, but if I give you a little booklet, you exactly know what I'm doing in my everyday life.
Yeah.
So I think that was incredible.
And that's such, okay, go ahead.
Yeah, I'll do it.
It's not a question, it's a comment. I want especially Michael and Caroline to be aware that the EIC is working closely with EMA, and I can't disclose too much, but we are being fundamentally raising the awareness of EMA on the ELMs have application in health, and some of the projects of the ESC ELMs portfolio, some of them here are directly involved in that conversation.
Thank you. Did we have another question?
Yeah, there's one more.
Oh, perfect. All right.
No, I just wanted to kind of add on the branding aspects, and I wanted to bring up the topic of world building and imagination and kind of how you portray the fields to the people around you also depends on the world that you're trying to create with the innovations that you're putting out there. And I think that what a lot of labs are lacking in is really creating this holistic vision of the world that they're trying to achieve by putting their innovation and technology out there. And I think that's because of that, for a lot of people in the general public, it stays on the abstract level and they're kind of just waiting for it to come. And they leave it down to the regulators to decide the fate for them, basically. And I think that if labs were engaging in more of design work, speculative design work, critical design work, and world building in general, kind of in the footsteps of Terraform, I suppose, or the work that's being done at the HBBE as well, I think that could create a vision that we all would want collectively as a society, instead of doing these iterative steps, as you also brought up, transformation versus taking incremental changes and then trying to achieve something that maybe is not achievable through incremental changes.
Sure. Thank you for that.
I think, so regarding this rebranding aspect, actually, I've been in admiration with some people in the US that have taken two different approaches. So one is like what you said, basically changing the name. So many people are calling it genetically engineered microbes. So GEM sounds much nicer. That's one way of going about it. Another one, like the company Z-Biotics, that is actually making a genetically modified probiotic that potentially cures hangovers. They label it as proudly GMO on their label. So that's another approach to say that, it's GMO, but it's actually good.
Sure. We're not apologizing.
So again, that's a bit of this world building kind of thing. Like, which world do you want to live in, right? Like, are you proud of the GMO that you created, or do you want people to think about it differently with a different name?
That's definitely a customer question. Like, especially when you're an end consumer brand, you can take these like proudly GMO. Like, this is something, if your customer likes an edgy product, like, of course, this is something you can use and create awareness for your product with.
So let's talk about this world building from prototype to scale. And I'm looking at Carolyn to jump in first. So what Terraform 1 and what you in the publication that you showed me, right, where people can touch and feel these various mycelium analogy-based kind of products and actually go, oh, this is what these people mean, right? Like that formula actually translates into something beautiful, gorgeous, functional, whatever it might be. There is a completely different reality to scaling that. And I know that when I was making the business case and cranking all the numbers for the Department of Education, and this will touch on maybe risk conversation as well, I was really unsure how to communicate that even from prototypes, we don't just go and make 30. It's a completely different process potentially to go from prototype to at scale production. And Carolyn, that was part of your experience, right?
Yeah, absolutely. We started, for any clinical trial, you've got to make material that you can, reproducibly demonstrate, meets criteria for the patients. But when we started off, you do very small trials, maybe just 10 or 15 people. And we were able to grow the material in our lab and freeze it down and send vials to the clinic. And then they'd resuspend it and give it to the patient in the clinic. So you start out really small like that, but you really have to, by the time you get to phase 3, you've got to be able to give the product to hundreds of patients. So that type of process doesn't work anymore. You got to be able to grow in fermenters at 300 or 1,000 liters. You got to lyophilize the material into a powder so then you can deliver it to a lot of people, across the world. So it really makes a huge difference. And I think that we underestimate sometimes what you've learned at, the 1 liter scale to the 10 liter scale and the 30 liter scale and what we've learned is a lot changes when you go up in scale, and the bacteria in a small flask are very different from in a large fermenter. So so that's an important learning that needs to get incorporated into the development from the beginning, because it's costly to do that, and you don't want to spend the money to do it until you know you have something that works. But once you have something that is starting to show it works, you're under enormous pressure to go fast, and then you don't have time to do the development work to understand scale.
Yeah, Melanie, your perspective on this, right? Because so much of, as you mentioned, these are prototypes, these are demonstrations. You put them in public places, you call them art, you have kids climbing these beautiful structures. But even the bench that we were sad to send back, I know that as a nonprofit, it's not your intention to produce anything in mass quantities, but what would it take to have a conveyor belt with benches like that kind of coming out? What do you see?
Well, maybe I want to take this discussion somewhere else, because I want to explore this. So I would say what I'm most interested in with my work is that I'm actually working in a nascent field. Now, it's like what Johan said before. It's like, okay, I come from biotech, and all of the tears that were shed by the artists and designers to find their place, it's somehow I came from the different perspective, engineering, architecture, and somehow there's biology. And just 10 years ago, almost 2015, there was William Myers, who curated the biodesign show in the MoMA. And somehow we were able to engage with him because we were exploring this nascent field of biodesign that didn't have a name yet. And there were not many people working on it. And so also, like, I'm a professor at the Rhine-Main University in Wiesbaden. And so from my heart, I just think that, like, education is also key to maybe scale up some of these ideas. No? So we're talking about scale up, but I don't want to talk about how I can produce 100 chairs. Let's hope we have thousands and millions in the future. No, like, we have applied this material somehow, but we also need to train the next generation. For me, it's like I train the next generation of designers and architects to hopefully implement some of these ideas. And I think going to conferences like this is also key to explore where some of these things can go to and maybe find funding opportunities whatsoever. But I think it's a very interesting aspect to kind of talk about how this field can develop somehow, from my perspective.
Yeah, I want to pick up your educational point, because there's something that we've been thinking about, and I have two children of, I'm going to forget their ages now, I would say,
it's only been 3 days.
My wife is looking at me. I feel under pressure. I'm going to say 8 and 13. 9 and 13. Yeah. So one of the things I've noticed is that, so this is a slightly different direction to the scale thing, but that idea of education early on is that whereas other sciences and engineering fields are taught in an applied way, we don't have, and certainly in the UK education system, a way in which biology is taught as an applied subject. As far as I know, and certainly at this stage in their curriculum, they haven't tackled the idea of biotechnology at all. And it's also quite a hands-off there's a lot less experimentation than there is, say, in physics and in chemistry, notably. And so we're not making biology into a making subject. And I think, therefore, we don't have people coming up until you get to university and even graduate school who are engaging with it in that way. And so, and I think that prevents a kind of talent pipeline. We don't inspire at that stage enough. And my feeling is that this specifically for the ELMs community is a way in, because I think an awful lot of biotechnology is quite abstract, but materials, particularly those of scale, of the macro scale, are tangible. There are experiments that you can do with mycelium or cellulose that you can do at home. It's a good gateway into that. And actually the processes that we've been using to grow mycelium, for example, are not so dissimilar. They are taken into a lab, we're doing extra things, but actually the same principles are there. And often it's quite agricultural. So the scale-up process, when it comes to materials, is farming, right? So we're just trying to grow things at scale and tend for things and care for things. So I think that, so my point is both the scale and education question. I think education at that stage, and I think the ELMs community has a role in doing that, because I think we do have a real tangible form of biotechnology, which is easier to understand for earlier year groups than perhaps the more abstract concepts that we get into later.
So should people in this room be going into middle schools to guest lecture? And I ask this in all seriousness because I've helped launch several professions that didn't exist. One of them is facilities management. It's one of the most, like, people who manage this building and maintain it, who are not architects, and then I'll come straight to you. That a profession did not exist 20 years ago. And so one of the things that an equivalent of I&M has done is it actually pulls professionals to do just that, to go into primary schools and middle schools and expose young students to this completely new profession to them. So would you go into middle schools and try some of that? All right, go ahead. Perfect.
That's just what I did this March or so. I went to a middle school and we did such a course combining art and science, and I presented ELMs as well. And I had a very strange experience. I was very enthusiastic, but the students live in a sterile surrounding. So the response was, it lives. No, I don't want it. So this was a very strange, and I don't know how to get away from this.
Yeah.
So I have the feeling we are going towards a GMO problem with ELMs. I'm, of course, going back. So I want to do it again and try again and to convince them this time even more. But I think we have a problem there.
Sure. And that's one of the reasons I see such relationships, and Wilfred is here as well, between the built environment and synthetic biology, even in the others, because built environment is where most people experience nature in a healthy way, right? So when our buildings have daylight, when our buildings have fresh air, which is one of the reasons I was so excited to work with the Department of Education, because they were going to go and spend $15 billion, unprecedented spend, on 200 new schools, plus all sorts of retrofits. So how amazing is that? If living materials is what kids get to sit on and touch and crawl on the floor, so that we're not having to rewire and erase bad understanding and replace it with good, because we can actually create those environments. Go ahead.
So thank you for this panel. And I've been sitting here, and there are so many things that
and
have
you also
come to
have
mind.
kids 9 and 13,
Yeah.
13 and 17 or something.
Yeah, 13 and 17. Wow, good memory. So, couple things, starting with you. I mean, one of the things that we do, we work on cyanobacteria, and we draw with them, right? So we draw on agar plates, and they get to draw patterns, and a week later they see what's there. And this is elementary school. And it's about the excitement that they get in seeing that they have produced something, and not necessarily telling them that it's a GMO or it's from the duck pond or wherever. It's just have them do something and build up a relationship, which brings up a couple of things. So, and I'm going to give the credit to Chelsea. So Chelsea took an idea that we developed doing a proposal and developed an art science exhibit at MSU. And with your permission, I'll show a couple pictures tomorrow at the end of the talk. It was pretty amazing to talk with people about what artists and engineers did together and how people related to it, which brings up my question. Why do we call ELMs engineered living materials? Why don't we call them living materials and liken them to things that we see out there in the framework of biomimicry?
All right. Any takers for the answer?
Or maybe I can jump in that, because I think the whole term came up more in academia, actually, and I think there was a bit of importance in making it engineered living materials, because living materials are trees also, right? Like there's living materials come up in the literature when you're talking about tissues, you're talking about anything natural also. So I think the engineered part was put in there to say that, yeah, we are doing something and getting in a certain direction. But I think that's purely like an academic sort of branding for, proposals, for papers, for all that sort of stuff. And maybe for the public, it is a good point to go back and say, these are just living materials. We made them, it's obvious, but...
And on that, can we just talk about the living part? Because especially as somebody who is not coming from natural sciences, I imagine that most of the benefits of living materials are in the living part. And yet, even to the bench and other things we've discussed, we're deactivating them. Maybe not in the pharmaceuticals, but in the built environment, definitely, which means it's heat intensive. It is really silly, right? Because here we've grown something that has the ability to self-regenerate, adapt, all of those things, and we've just sort of killed that off. What would it take to actually not deactivate? How do you see the steps that need to happen so that we actually, and I would imagine that's Navy's interest as well, to actually be able to grow, things on a naval base that can actually repair itself if it gets cracked or whatever it might be. So how do we get there from here?
So, of course, yes, that's definitely what we're interested in, is that self-healing, growing in the field, being able to produce something that's alive. But the military is special, right? We don't follow the same regulatory guideline because we're able to test things in a real-world setting and see how it behaves, and we're not as limited by the LC requirements, right? So the ethical, legal, societal, and whatever that stands for. But it's the component that you often have to consider in the U.S. when you're writing an NIH, an SF, or even a DARPA grant these days. But I think that's the sell, if you will, right? What we're interested in, that's the sales job, is that idea of eventually we will get to a point where we're allowed to release something that's alive. But we're definitely not there today, which is why we still have to heat kill or we have to autoclave. You can create this illusion, right, of not being alive anymore. But all of us, and I think most of you in the room, eventually want to get to that point where you have a living wall that if you scratch it, it comes back, or you can change the color if you shine a UV light on it. And that's where we all want to get eventually. But we're definitely not there today for the reasons that we mentioned, right? It's a branding thing. The vast majority of the population is afraid of this idea of a living material, despite the fact that most of the things we deal with. But I think we use that concept because as a community, that's where we all want to go eventually, and we see the value in it.
Okay. Martin?
Yeah, I wanted to also to challenge the idea that there's a sort of a moment at which something becomes living or not. So I was thinking about this yesterday because classically, actually, Phil Ayres said this in his presentation, that this room is full of dead materials, essentially. It's constructed of dead materials. It's actually not. These materials are teeming with life, absolutely teeming with life. It might not be terribly useful for us, or we might not perceive it as being that useful, and we certainly can't see it, but it's all there. And actually, one of the things in the centre when we set it up is that we had one of our major research themes was the microbial environment, because actually this environment is useful to us. The interaction between the environmental microbiome and our health is really very important. And unfortunately, post-COVID, I think the fear of living things is partly for a generation who've come through that fear of these invisible, this invisible threat. But actually, it's already there. And I think if you look at the papers and the posters in this conference, there is also that grading of that livingness as well. So there is dormant potential in things like spore work encapsulated in material. There is what we've been presenting, which is we call them dirty ELMs or low metabolic materials. So materials that do retain a microbiome that can be reactivated and enhanced in some way. And then we've got other examples where we need to then build things like vascular systems and so on in order to allow nutrients to flow. So I think there's a kind of gradation that you're already seeing within the ELMs community of different ways of thinking about living and dormancy. And actually within the realm of ELMs as well is also the step of the production of materials being engineered living materials actually, but they often lead to a material which is fundamentally biologically dormant at the end. It's killed, frankly, to as I say, and to things that are a little bit more than that. So I think it seems to me that the technological development of that will follow that line as we get more and more life in our materials or more lively behavior.
Yeah, I would like to add maybe a different perspective. So basically, we, like with our microalgae biofilms that we have been deployed with our customers already for quite a while, we kind of know what it means when you have something living with the customer, and it always means that first you have to educate the customer how it's been handled and what happens if something goes wrong, because something will go wrong. And secondly, the customers are usually pretty willing to learn, and they like to learn like incrementally. So if they do something wrong, you kind of coach them again, and then they do it better next time. But they kind of really want to understand what's happening. So I think that's something that you can especially get done with a living system, because it changes, and the customer kind of wants to understand why it changes. Especially when we kind of took our materials and we put them into larger scale, what we liked was that I think somebody yesterday was also saying it in a presentation. You have like this kind of plug and play situation where you don't have to have a crazy bioreactor in place for the application, but you rather have a simple container. You put in the material, you use it for 3 to 6 months, and then you replace it, right? This is actually a flexibility that cuts a lot of costs for the operators. And then if you have a living material, of course, it goes towards how do you sustain it, how long can you use it, what's the maintenance rhythm, how much does the maintenance cost, how can you achieve it. But yeah, you have to have a good concept how to bring all the nutrients there, how to keep it in a good shape. And maybe one of the solutions is on our poster, poster 7, because in our research we develop biotubes, which is a good way to kind of supply organisms with nutrients for a long time.
Appreciate it. Sure.
Yeah, I think along this discussion with like gradations of life and so on, I think we have a really good example here, because the bacterium from Synlogic basically doesn't grow in the body. It was engineered not to proliferate within the body. But then the one that you talked about, the living therapeutic, isn't limited in that sense. Like they can grow in the body, right? So
actually the project I've been working on is similar also to Caroline's one, because it's once the GMO or the cells that you introduce into the body can grow, this is of course a safety concern, and you need to characterize very, very well. Actually, it's theoretically yes. However, under the conditions that are outside the lab or inside the body or where it's applied, it cannot. And that's also, at least in the application we have, it's also supposed to be like that. The other thing related to this, and this is also a complexity with the GMOs or cells you apply, you need to apply a certain dose, and based on that you have usually a PK profile on the effect, the therapeutic proteins or the whatever is happening based on the mechanism of action, and this you need to understand very, very well. Yeah.
Well, let's stay with this a little bit as we transition into funding. I want to invite you to talk about risk a little bit more, right? So Johan was just mentioning things will go wrong. How do we educate our customers and our investors about these risks, many of which are not experienced anywhere else, right? Again, this is a new transformational reality. So how do we do this without freaking people out to an extent where they just don't want to have anything to do with it? Maybe give us some examples of where you might have overdone it, underdone it. Where's the happy sort of medium that you're finding when you talk about risks associated with your work?
Like maybe I can start, because it's like a conversation I had often. I mean, I don't do GMOs, so maybe it's a bit less complicated. But for us, it was always really easily when comparing it to living systems that everybody knows, like your house plant or your garden or something. So always to find an analogy everybody knows in their real life was a really good communication tool to also kind of convey kind of a bit more complicated thing.
Yeah. Okay.
So the U.S. Navy is risk averse. No, I mean not risk averse. So that's my job, is to find risky research and invest in it, because we of course expect science to fail 70% of the time, or more, 75% of the time. And so the U.S. structure is very different than the rest of the world. You know, oftentimes when I travel, people don't want to talk to us because we're the Department of Defense. But anybody from the U.S. knows that if you really want basic kind of crazy science funding, that you go to the DoD. The U.S. Navy has something like $2.4 billion a year that we invest in science and technology development. And a lot of that is at the very basic, let's just see what happens kind of level. And so in the U.S., if you want to do something wild that no one else has ever done before, the Navy, the Army, the Air Force, the Department of Defense is your customer. And so we like to hear about those crazy ideas. And in fact, most of the time when people come to me and engage with me, I always tell them, I'm like, if you tell me something that I've already heard before and it seems feasible, I'm not really interested, right? So I worked in a lab, I wrote my fair share of proposals, and, you know, I tell people it's like, if I look at your proposal and say, I could go in the lab and with X amount of money and time, I could do this research, not something the Navy's interested in. So yes, for my customer who I sell to, we like that risk. And because we understand that's how science goes, right? You're going to come to me with some crazy living material that'll grow me a tent in the woods. And I'm going to say, wow, that sounds incredible. You just drop it in the jungle and you come there a week later and there's a tent. Maybe it has water and power. That would be really cool too. I could definitely sell that, right? I would find someone who would say, yes, please. And we'll give you some money to see if that happens. And we all know that it probably will not happen in the next decade, but that's okay. Because you're going to learn along the way what went wrong, why didn't that work, you know, what conditions were wrong. And so, again, I'm very spoiled in my job and having worked for the Navy as well, because you really do get to explore those crazy science experiments. You don't have anybody looming behind your back saying, did you hit that milestone? Where's my product? And the like.
So Scott, I'll go back to anybody else who wants to jump in on risk. But while you're on this, so what else do people need to know about approaching the military for funding? Because it sounds almost too good to be true. And I would imagine that there are some people here sitting going, well, how do I even begin that conversation short of cornering you with a glass of wine?
That works. So yes, I mean, the Navy, the U.S. Navy has been here for 80 years in London. That's our headquarters. And I'm sure most of you have never heard of the Office of Naval Research Global. We don't advertise. We don't even have a good website. You know, we're very behind at the time. Yeah, I know, right? Imagine that. But fortunately for me, that means I get to travel the world and say, hey, I work for the Navy, and give me a call. So it allows me to go everywhere. As the Navy, there's 26 of me spread across the world. We all do something different. I'm lucky in that there's only 2 biologists, but we do quantum, material, power, and energy. And I like all the real Navy-sounding stuff. So the best way to engage is to run into me or someone like me. Sorry, but we all dress the same. Check us out, right? I'm in a boring, nondescript suit. But the best way to do it is to find us on LinkedIn, to meet us at a meeting, take my card. Oftentimes what I tell people is like, send me an email, because we have a very non-conventional way of reviewing research, right? We don't have an active call. You don't have to send me a proposal by the 15th of April or anything like that. We often tell people it's like, send me an email and tell me what you want to do. And I'll tell you very quickly, the Navy's interested in it. The Navy's not interested in it. It's not crazy enough. Oftentimes what I say is, I'm not interested in that someone in the Army is, right? Because we all have our distinct lanes, or the Air Force or the like. And so really when you meet one of us, you're kind of connecting to the U.S. network, right? And so my whole job is to take your crazy, it's got to be crazy, research and help you find a partner in the U.S., preferably with the Navy, because we're the best, but oftentimes some of the other funders as well.
So what not to do? Just quickly, any advice of what to avoid in approaching military for funding?
Just have an open mind, because especially in Europe, you know, a lot of people, like I said, you look at the Department of Defense with not rose-colored glasses, but they look at us in an unfavorable way. But what we are really looking to do is really to push the science forward. I will say that I am agnostic to an application. When people come to me and they're like, I have this great technology to combat UAVs, and they're like, it's an application. I'm not really interested in that. And so for the Navy, the crazier the science without an application, the better. They will say we don't fund medical stuff, but we're really good at spinning that language so that it doesn't sound like medicine. So when engaging, really just come with an open mind, be willing to share your ideas. Even if we don't fund your research, often we'll help you find a partner in one of the Naval or Department of Defense laboratories who's doing something similar, which opens up a whole new door for you, right? To have access to those testing facilities, their funding streams as well.
Sure. So the rest of the panel, just any of these threads, right? So how you communicate risk to investors, what has and has not worked in raising money, kind of faux pas to warn others against. Go for it. Go ahead, Michael, and then Martin.
So maybe, so first of all, in my area, what really is important, so what is basically the microorganism you have used? Because sometimes there are already decades of research of the respective microorganisms. And then, of course, if you modify it, usually you can also characterize as well. Nowadays, you can do something like next generation sequencing. You sequence a full genome. You know exactly what is happening in the genome and so on. And so related to that, so in the project I have been involved with, this was a modified Lactococcus lactis. So it's also in dairy product. So if you spill your yogurt, you also spill Lactococcus lactis. So from our perspective, the genetic modifications that we have introduced, that should not render so much the safety profile. Of course, then the difference comes if you want to use it in specific clinical or therapeutic applications. And here, of course, also you have regulatory guidelines. And now it gets a little bit complicated because we have genetically modified cells, and this is not trivial. And I think what really works towards investors is that you understand the difference between the traditional drug developments, like for small molecules and for cell and gene therapies, because you don't have to do the full program, because sometimes certain data, it's impossible to generate this. And you have to understand and also communicate to the investors with the appropriate justifications.
Thank you. Martin, and then Carolyn, I would love to come to you for that as well. Go ahead, Martin.
Yeah, one of the things that we've been thinking about is whether we're well served with a current definition of technology readiness levels for biotechnology, because if we think about what we're doing with biology, we start with a technology. If we look outside, we see a technology which is already at TRL level 9, right? If we're going to look at the trees as a technology, which is a weird way of doing it, but that's what you get.
Not according to Aristotle.
There we go, yeah. At TRL level now, we take them into our labs and then we get to TRL level 1. So we get now plant cells that are growing on little dishes and doing one of the things at a small scale. And then the TRLs kind of click into this sort of mode in a lot of the definitions, and I know there's more than one. The EU has one, NASA has one, so where we talk about scale. So it's a lab bench scale demonstrator. And I guess if an investor's considering investing in a technology that is at certain stages in that TRL level journey and wants to, say, take something at TRL level 6 onwards, we then get into this issue that you get something that works perfectly at TRL level 4 if we're to associate it with the scale, and then definitely doesn't at 5. It just completely breaks down. And I wonder whether we need better rubrics for understanding where our technologies are at, better ways of describing them. I don't know there's a single one, but I've often been stumped by the TRL level question, because often we're also aspiring, as I say, to do things that are proven in nature. So we're dealing with mechanisms some we know work, but they become very different when we're trying to use forcible constraints or whatever it is. So I don't. One of my PhD students has started thinking about this, and slightly in a collaboration with NASA as well, whether we need a separate biotechnology TRL that ask the question, or maybe more than one stream. But it's felt that that's difficult for us in funding, that definition of where we are, and therefore the risks associated with different TRL levels, early or late, becomes related to that.
Sure. Well, Carolyn, as somebody who's gone further than anybody else, right, in terms of clinical trials, what do you know about raising money now that maybe you didn't, and what is changing in your approach as you go to the next step?
Yeah, I guess I've learned how fickle investors are, and that they want to see very fast turnaround of results, and in developing any therapeutic, it's a long timeline. And so trying to figure out where you can have inflection points and milestones that give the investor more confidence is really critical along the way, and really thinking about how you structure that into the drug development process, not just, what is the regulatory agencies, investment community going to need to see to keep them putting more money in. And then how are you going to mitigate when you have something go wrong? Because, as soon as something goes wrong and it doesn't work the way you expected, the timelines increase and then investors will pull back. So having an investment strategy that is diversified so that you get funding from big places, you have resilience when one funding agency decides that, because you stumbled, they're not going to come back and give you another round of funding. You might have another source. So, combining things like grants and collaborations and, with the capital markets is really critical for success.
How good is the ecosystem of funders around living materials? I ask because the other industries that I've helped accelerate, it is one of the hardest things that when you graduate from seed to Series A to Series B, there is no handover, which is what you get in more mature industries, right? Where you actually get references from your seed funders, and on it goes. And you probably are experiencing a much more fragmented funding world, Yeah.
And I think I mentioned earlier on, never say microbiome. That's because all the funders of bacterially based therapeutics came up from this sort of surge of energy in the microbiome space that was happening 2015, 2016. And then one company failed and everybody pulled back, and they pull with it went all of the funding for bacterial therapeutics that were engineered, which were never microbiome therapeutics. So, I think a message that, takes you to a new set of investors is to be able to have that diversity of funding that you need and not be tied to something that really isn't you.
Yeah. So, and also if you want, and then I'm going to ask to see if we have any other questions or comments from the audience. This idea of spinning out and people not really wanting to deal with universities on this, just maybe a couple of you commenting, because that was a really interesting discussion in prep.
Maybe I can comment quickly. We were really lucky back then because we got when we founded the company, we got a stipend from the government basically to get going. And the good thing was about it that we did not have any formal connections to the university, so all our IP was ours. Because that's exactly what I know from investors' talks, that once in universities are within the IP, it just complicates things, and investors don't deal with transfer offices. Like, I have never heard of a successful collaboration between a universitarian transfer office and an investor, but that's only my knowledge. Another thing I find really critical, especially in the biomaterial sector, is that the investors I met, and I made about, you always have to adjust the pitch deck. So when I started Solaga, I was like, I know I make a pitch deck and then I have it for later. No, I made roughly 150 of them.
That's right. Probably for 150 meetings.
Yes, right? Exactly. And what I've really learned was that investors don't like asset-heavy investments, especially when we make new biomaterials. If it's mycelium or algae-based products, there's not a market out there yet where, in case we go bankrupt, you can kind of use the same asset and kind of sell it to competitors or something, right? So it's basically a high-risk asset you have to invest to, and it's just for the investors too high of a risk. Mm-hmm. So I think especially in Europe, it's difficult to find funding, especially for growing production. But on the other hand, maybe there are some like EIC and European programs that are helping out there. Yeah. I'm not familiar so far, but yeah, what I wanted to.
Melanie?
Yeah, I just want to briefly bring in a little bit of a different perspective, because I often work also in this open source community. So our approach is not, okay, I need to own this patent and, this and that, but maybe also to actually break some of the barriers that kids have with experimenting with these materials. Maybe we just have to open source our ideas so people can experience them. They can DIY them at home. No, there's a whole DIY concept out there. And I think that would also be a very interesting aspect. Maybe design is a much easier way than pharmaceuticals, or drugs that are obviously much more complicated. But I think design maybe can break this barrier into ELMs, GMOs, synthetic materials, or bio-based products.
And how could we do that? Because look, this co-creation, open source, whenever we have emerging industries, it goes such a long way, right? The moment we all start shutting our doors and putting our little plaques and our patents, it does unfortunately slow down transformation, not innovation in your thing, but transformation of the industry. So any examples, any insights, any ideas of how maybe we get the best of both worlds? Because of course, patents are critical. You live and die by them. But how might we bring more of this co-creation, collaboration into this space?
This is a tricky and difficult question. And when we started this center, it was with the idea that everything that we produce would be open source and we wouldn't go for patents. And we've had conversations about really interesting ideas where do we publish or do we go patent? And we tend to go publish route. I've changed my mind a little bit in talking to a patent lawyer. Admittedly, the patent lawyer probably has a vested interest in this. But the point they made to me is that, okay, it's great that you're doing TRL level, that's that again, 1 to 3 work. But you're going to, if you really want your thing to have an impact, it's going to take millions and millions of pounds to get this to a point where it's going to make an impact. Someone's going to have to pay for that and someone's going to want a return. And so the moment you publish on, there was one particular concept that we published on, they said that concept is probably dead to industry at this point. Now, I wish it were not so, and I think there are examples in the software world of open source working incredibly well and producing really robust things and proliferating. But a lot of this biotechnology is so hard to do. It's very, very difficult to do on a community basis. It requires a huge amount of investment in resources and equipment and these sorts of things. That for us, it's a question not of earning any money back from these things, but of sustaining the expertise and the resources that we need to make anything that will have impact in the world. And so it's a challenge for us. And we talked earlier about this, that the universities are often, certainly our universities in the UK, feels are not very well set up to deliver that. And so they're not very supportive of patents unless there is a direct route to market. So we publish or perish, that's what we do. But I've become more hawkish on this question for the reasons of people's livelihoods as well. You know, our postdoctoral research is their future careers, how we sustain this generation of talent. There has to be other forms of sources other than the TRL level 1 to 3 funding that we rely on.
Sure. Well, we're going to shift gears into synthesis. So I'm going to, in a minute, ask every panelist to think, what is the one action or one priority that over the next 1-2 years would make a profound difference to the rate of development and uptake of living materials? So as they're reflecting on that, any other comments or questions from... Okay, go ahead.
Sorry. Comment about the technological readiness levels. There is relatively recently one that's been kind of laid out for biomanufacturing from, there's this DoD-funded advanced manufacturing funding agency to some degree called BioMade in the U.S., and they've kind of laid this out in that 2022 publication, Mike Szymanski. It has some intermediate levels that are a little more tailored to biology than kind of broad technology, so that'd be worth looking at.
Go ahead.
My question goes around the topic. It's been more or less, it's been tangentially covered before, but I wanted to raise the question on how do we join forces with all those little changes that are needed to be made in order to make this transformation? Because of course, like, this movement is definitely recruiting like engineers, biotechnologists, and now designers and architects. So the disciplines are expanding, but how can we ensure that all those spaces where progress is needed towards the direction of transformation are properly aligned and handled.
Well, I might just jump in on that. Roadmaps are really helpful in this, right? And we were just talking, is that the role of I&M? Is that the role of another industry body? Often there are so many moving pieces, as you're describing, so many disciplines that don't even speak the same language, that are rarely in the same room. Many of them don't even like each other. So this is whenever we do movement building, we start kind of with that. So roadmaps that begin to articulate, these are the pathways, and it's always dynamic. It's never rigid, but probably painting that picture with some key thresholds and then having industry get behind that, including the question that I've just posed to the panelists of, okay, all of us focus on this for the next 12 months, right? Whatever your expertise, we're trying to get this message out to the market where we're trying to, whatever it might be, and then we move on to the next thing. So these roadmaps that are become a shared industry strategy are one of the ways that we sort of do movement building around that. And of course, education, language, storytelling becomes a huge part of that. And rarely is that done. We're really lucky here, but rarely is that done by the people initially in the room. So it's when you get people from the advertising industry interested, that's when you know you're really making it, right? Because they're really good at communication. We know that they can sell us even things we definitely don't need. So starting to pull in this additional expertise. I've worked with cartoonists. If we can get to Hollywood and media, right, this is when you really start kind of changing people's perceptions. So any other answers to that question of how do we weave this together into a movement? Anything in particular you want to see that would help you?
I have one common area. So we had a ELM workshop in Montana last year, and as a result of that, there is a seminar series out there that you have presented at that we do online. There is a Slack group in which we try to share both publications, but it could be a venue to actually share outreach activities. And I encourage everyone to join. Look for living materials on Slack. Please join us. There's no obligation. Another point comes to patents and how to work with industry. I was very lucky to work on an R&D project, which was supported by the Department of Energy, where we started working on using biomineralizing bacteria, that's my other life besides phototrophs, to seal leaky wells. And we worked with Schlumberger, which had a carbon sequestration division, and they shut it down. And we were lucky that the engineer that retired as a result of it said, this technology is going to work. And he ended up working with us for the next 4 years and 5 field demonstrations. And we made it work. And there's now a company that has sealed 100 wells. I don't have any financial interest in them. I'm not going to present on that tomorrow. But our university, we had patents, and they were, for better or worse, abandoned. I am in a position, I totally share your thoughts. I'm in a position I can be very proud and very happy with it. But the people that worked on this in the lab, some of them are now in faculty positions, but others aren't, and that was their livelihood. So it is a hard line to walk. But this comes back to my third point that I forgot earlier. So communication, and we've brought this up a number of times, is a key. And when we went to an oil well in Indiana to actually seal a high permeability zone to enhance oil recovery, we were thinking about how do we communicate this to the farmer. We have a trailer in his field, and we're growing hundreds of liters of a bacterial suspension. And we talked about this beforehand. And we basically said, he came in and we said, we're doing bacterial farming. We're doing bacterial agriculture. And he, oh, yeah, they are producing the same enzyme that you harvest from soybeans or jack beans. And he, wow, this is cool. And he was in there for half an hour one day and another hour the next day, because he was so curious.
Yeah.
Just by relating it
to what they're doing, whatever part of relation it is, it makes a world of a difference. And we're not necessarily trained as that in that area as scientists, but maybe that is one of the areas that we can train ourselves better in.
Well, sure, engage, right? I mean, imagine if you got a Netflix show, right? I mean, think of how many fixer-upper shows, cooking shows. You think your kid can dance has actually made dancing cool, right? And all of these kinds of things. So if there was a Netflix show in that future where all of you throw your intellect in to solve a problem or a leaky well or whatever it might be, and things are growing and things are, these are the kinds of things that really start shifting culture and opening these doors. So
there's one last.
Yep. And then summary and closing remarks. Yeah.
I just wanted to throw in just a little addition to something that made me think of Robin. So just because of sort of where these technologies are right now, it seems like the ELMs that are kind of more positioned around sustainability and sometimes biomineralization, some of them are a little closer to being market technologies. So, for example, Prometheus comes to mind, and some others. And there's maybe like a burden of that component of the research community that like we're kind of like mixing with the public for the first time and how they interact with those technologies. And so I think it's really helpful for us all to be on the same page about how we talk about those materials and help each other out. And that might pave the way for how we talk about our healthcare material. Sure. Right? Because it's in those spaces that people are sort of becoming challenged with, just like we talked about before, thinking, oh, right, there are living components to my house. But that doesn't mean the same thing as like the villain on The Last of Us, right? And but seriously, I get that question almost every time. Anytime I give a talk at a non-ELM conference, people are like, do we want fungi in our wall? Right? Like that's always the question. And it's like, but as we, just laughing. No, but literally, right? And so, but that as we work out some of those communications issues that are relevant to the ELMs for sustainability, especially since some of the systems don't always have engineered microbes. Some of them just have microbes for purposes that we care about, and it sort of deconvolutes the issue. It maybe gives us an opportunity to pave the way a little bit, and maybe if we do it right, line things up for the ELMs for healthcare to have a more successful path. Sure.
I appreciate that. Well, just in a bit of summary, and then I reckon we go from Scott kind of that way with your kind of closing last thoughts, and Shirish finish with you. But we've covered a lot, right? So we've started with stigma, talked about branding, rebranding, marketing, communication, this loss of purity that we often experience when our baby of a solution emerges into the world and has to kind of take it on. Talked about living and once living, and what it might take to actually get to the future that we discussed. Talked about the role of prototypes and what we gain and lose when we go to scale. Talked about the role of design and art and introducing these prototypes and these futures kind of into our lives. Talked about how we raise funding, including through the military, what to do and what not to do. Talked a little bit about the obstacles around regulatory environments that did not allow you to go to trial in Europe, but you were able to go to do that in the US. And talked about even patents, right? And publisher perish and co-creation and open source. So we covered a ton. So to the question of if there was one priority that you feel like we collectively can focus on in the next year or two that would make a profound difference to accelerating this movement, what would it be? Scott?
Now, education of the masses is probably the most important thing, because a lot of these technologies are really close to market, right? Making something, a material, or something that's tangible that people can touch. But, like you allude to, anytime I talk about engineering fungi and something I'm going to fund, my wife, who is a public health epidemiologist and educator, says, should we be engineering fungi? So I think educating people as to the potential and the overall safety of these materials and what you want to do is you want to get your audience excited, right? And so for that, you have to bring them into your vision and into your dream, teaching the young children, my 3 kids are all science nerds, right? And dissect.
Did they have a choice?
It's in the blood.
All right.
But I think what's critical for all of you as in me, as a community, because I educate the people with the money, is really to explain to people what you're doing and what your vision is, and not as a scientist, but more as a visionary, right? So I always see scientists as artists, right? We create, we have these visions, we just do it in the lab instead with a paintbrush. But it's the same thing, and you really have to get people excited about that. And so focus on sharing your vision with your community and outside of your community, more important, right?
Appreciate that. Johan?
So for my closing remark, I would like to emphasize that I think a lot of the problems about the visibility and understanding in the public that are present in understanding your research fields, maybe they would not be so present if there was actually like designers and artists being involved in the research directly from the beginning and not from the end, because I think especially along the way, even if you start with something very complicated, I think designers are really good in grasping the issue and putting it in perspective, and also always testing the perspective if you're aligning with it. And so I would really wish for the future that this would be possible, to have a more closer relationship between designers, artists, and scientists. And I would really wish that also funding bodies would this include in their programs.
Carolyn?
Well, I'd love to have an investment safety net, because when a company has to close because of a failure, it's a tremendous loss of knowledge. And so, I think
even the word failure, we got to rebrand that as well.
We need to, there are ways to address problems. We're all scientists. We address problems all the time. But when the rug gets ripped out from under you, you don't really have the opportunity to address problems, and it's a huge waste and lost in industry. So that would
funding safety net. Yep.
Safety net.
Michael?
If I have one priority or also wish, it would be more cooperation, facilitate synergies, because I think there are a lot of things that all our projects or areas have in common, also challenges we have in common. And so from in my area at least, there are also, for example, and Caroline mentioned it as well, big shortcomings of for manufacturing. So usually you would go to a contract manufacturer where you can outsource, especially the upscaling. There are only very, very few companies who do something like this in Europe. And if we could bundle this together, there would be really the possibility to build up more this infrastructure. The same thing goes also for other service providers, like for the analytics. We also need people who work in the R&D space who can do troubleshooting, because there are always in innovative projects hiccups or shortcomings. And of course, we also need an active funding community, not only private investors, but also public funding. And the reason why this is so important is, I mean, on the one hand, of course, we can accelerate, and we can also then test more innovative approaches. But on the other hand, we also have to think about the cost effectiveness in the end, because we can develop something that is super fancy, but if in the end it is too expensive, at least in the therapeutic area, probably it will not have the acceptance we want.
That's right. Thank you, Martin. What would you do with your magic wand?
I mean, just prosaic things like more funding and more better equipment and that kind of stuff. Now, I'll finish with an anecdote. So there's a show in the UK called Silent Witness. I don't know whether there are equivalents, but it's a police procedural about forensic science. And we were script advisors on one of the shows, and the story was that there was a murder committed in an ancient ruined building. And the case had gone cold, so no one could pin down the murderer and the murderer. But it so happened that there was an experimental group doing some self-healing stone-based bacteria in the environment, and that led to the formation of particular crystals of a particular size and shape. And if you want to know about that, you should look at Jamie's poster. And that was enough that these particular shape of crystals were found in the boot of one of the suspects, pinning them to the site. So engineered living materials helped solve a crime. So I'll leave
that to see whether that's a good or a bad promotion of a field.
Very nicely done, Melanie.
Yes, so I think my final remark would be continue growing this community, opening it up to as many interested people as possible, fields as possible, and really trying to push some of these ideas to solve also some of our planetary urgencies.
And for me, it's I've seen this community grow for quite a while now, and it's expanded horizontally a lot. Like in 2020, when we had the first conference, we were like, oh, you can do everything with ELMs. And now we're seeing, yeah, we can do everything with ELMs, but everything's at a proof of concept stage. So I think we've explored a lot of space. If there's something that I would like push for the community to do in the next 2 years is at least 10% of the ideas, try to tech transfer it. Try to get into the idea of getting it into society or commercialization. And it's a hard task. I mean, it's something that we kind of started exploring also. But hopefully in 2 years, we are having discussions more with everyone about, oh, shit, I tried to get that funding, or I tried to get this investor, or this regulation's bothering me. And that's where the community will get everything into society and commercialize.
Appreciate that. We have one comment right behind you. And then I'll wrap.
You opened the door for me. What the EIC for. And we do offer free services to our projects to start to, put the seeds in preparing the results that they obtain for future exploitation. Some of the services are available to graduate students and postdoc, so no hierarchical preference there for once in the commission. So we're going to, all of you are funded by the EIC, where it's going to be a beneficiary days on November 20th online. So back your coordinator if you want to learn about these exploitation services so that you can answer their question in 2 years.
Terrific. Thank you. Well, on this note, would you please all join me in thanking this extraordinary panel?